Hello and welcome back. In this session, we are going to look at an introduction to the load balancers. Now, in the last session, we looked at your network interfaces. So, we understood what your network interfaces are, what are the various attributes that it contains, and why we need the network interfaces. Now, in this session, we will start off with an introduction to your load balancers. We'll understand why we need the load balancers, and then in the upcoming sessions, we'll also look at the different types of load balancers we have. Once again, before I start off with the session, please don't forget to hit that subscribe button. So before I start off with your load balancer, so before we understand what these load balancers are, first we need to understand why do we need a load balancer. So imagine we have a web application which is accessed by millions of users worldwide. So we have lots of users, we have an application, and this application is hosted on a server. So let's call it as an EC2 instance. So we have one EC2 instance where our application is deployed, and then we have millions of users who are accessing this application. Now, let's say as the users increase, right? So let's say we have million, now it has been 2 million, 3 million, 4 millions, and then so on. So as the users increase, the load on the server also increases, which will impact the overall performance of the application. So it could be like the page takes a lot of time to load, or it times out. So various types of performance issues. Now, how do we handle that? Now, one option we have is we can increase the number of EC2 instances. So instead of having one EC2 instance, we can replace that with two EC2 instances, and we can deploy the application on both of these EC2 instances. However, the next challenge that we have is how do we handle the load between these two instances? How do we distribute the traffic such that some of the users should access the traffic should go to this EC2 instance, and some of the users traffic should go to this EC2 instance. How do we distribute the traffic between these servers? And this is where your load balancers come in. So one more example I can give you is, imagine we have a car which can accommodate 5 people, but somehow let's say we put in 10 people in that car. Now what happens is the load on the car has increased, which will affect the overall performance of the car. Now uh, how do we solve this? Now what we can do is, instead of having one car, we can have two car, and then we can distribute the passengers. So we can have 5 people in one car and then the other 5 in the other car. That way the car will give you an optimal performance. The same can be applied with your servers as well. So depending on the server type, the capacity of the servers can handle only so much of traffic. All right, so to handle this, we can make use of your load balancer. So elastic load balancing takes care of automatically distributing the traffic, whatever the incoming traffic we have. It automatically distributes this traffic among the multiple targets that we have defined. Now these targets, it could be your EC2 instances, it could be your containers, it could be your IP addresses which are running in one or more availability zones. So you don't have to worry about distributing the traffic across the servers. The load balancers will take care of it. So this load balancer will act as a single point of contact. As a user, we will be hitting the load balancer, and as the load balancer receives the incoming traffic, it will automatically distribute the traffic among the available targets that we have defined. So in addition to handling the traffic, it also takes care of monitoring the overall health of these targets. So it makes sure the traffic is sent only to the healthy targets, and if the targets is unhealthy, the traffic will not be sent to those targets. So the load balancer will monitor the health, and it will ensure that the traffics are routed only to the healthy targets. Now, your elastic load balancing scales your load balancer capacity automatically in response to changes in incoming traffic. So what are the benefits that we get out of this load balancer? So one main benefit we have is it helps you to distribute your workloads across multiple compute resources such as a virtual server. So that's the main benefit that you get with a load balancer. It will automatically handle the traffic for you. It will automatically distribute the traffic across multiple machines that you have defined. The next benefit we get is Using a load balancer, it helps you to increase the availability of your applications as well as the fault tolerance of your application. So let's say for some reason this EC2 instance has gone down. You still have 3 EC2 instances where your application is running. So the availability of your application is high. Likewise, the load balancer can handle the fault tolerance as well. So if there's some issue with this, the load balancer will not send the traffic to that server. So it is also handling the fault tolerance for you. Now, with this, you can also add and remove your compute resources at any point you want. So let's say these 4 instances are not sufficient. You can add 2 more servers to handle the load. Or if you feel like 4 instances are way too much, you can remove some servers to handle the load. So you can do that as well. So you can add and remove compute resources from your load balancers as your needs change, without disrupting the overall flow of your requests to your applications. The last benefit you get is you can also configure health checks. So as I was telling you, you can also configure health checks to this target such that your load balancers will monitor the health, and only if the servers are healthy, the traffic will be sent to those servers. And if the health check fails, the load balancer will not send the traffic to those servers. So you can configure health checks which continuously monitors the overall health of the compute resources, so that the load balancer will send the request only to the healthy ones and not to the unhealthy EC2 instances. All right. Now, whenever we talk about your load balancers in AWS, we have 4 types of load balancers. So we have the application load balancer, we have the network load balancer, we have the gateway load balancer, and then we have the classic load balancer. So classic load balancer is a very old load balancer. Application load balancer, network load balancer, and gateway load balancer is something that you will see people using very often. And classic is a very old one, and not many people are using this as of now to manage the load on their application. Now in the upcoming sessions, we will be looking at each of these individually, and there's no cost with this load balancer. So with your load balancers, you only pay for what you use. So again, it follows your pay as you go model. So depending on the hits, depending on the time, the EC2 instances, so whatever you're using, you're only going to pay the money for that. So that's about your introduction to the load balancer. So once again, load balancers are used when you want to handle the load on your EC2 instances, if you want to make your application highly available, and if you want to make your application fault tolerant, we can make use of your load balancers for that. That's all I have for this session. Thank you. Once again, before you leave, please don't forget to hit the subscribe button. And if you like the video, leave a like and please share the video.